Module 4, Lesson 7, Replacing Letters with Numbers. Learning targets. I understand that a letter represents one number in an expression, and I understand when a number replaces the letter, the expression can be evaluated. Let's start with example 1. What is the length of one side of this square? One side of this square has a length of 3 units. What is the formula for the area of a square? The area of a square is equal to s squared, or you can say area is equal to one side times one side. So what is the square's area as a multiplication expression? So we are going to take our 3 units, and we're going to substitute that in to each of the s's. So as an expression, it is A is equal to 3 units times 3 units. So what is the square's area? All we have to do is multiply 3 by 3. So the area of this square is 9 units squared. And remember, area always needs the exponent of 2 after the unit of measure. Example 2. We have a square that has a side length of 23 centimeters. So what is the area of this square? So we're going to use our area of a square formula, and that is A is equal to S squared. And now we can take our side length and we can plug it in for S. So now we have an expression of 23 squared, and now we can solve for the area. So 23 times 23 equals 529. So our square's area is 529 centimeters squared. Example 3, we are going to be filling in the boxes with the information from our 2 squares. So we have one square that has a side length of 4 and another square that has a side length of 25 inches. So we're going to fill in our boxes for length. So I have filled in the first box with 4 units, and since it doesn't have a unit, I'm just assuming that it's on a grid, so it's going to be units. And then I have filled in the second box for length with 25 inches. And now we're going to write our area as an expression. So our expression for the first square is 4 times 4, and our expression for the second square is 25 times 25. And the last thing we're going to do is we are going to solve for the area. And so our area for square 1 is 16 units squared, and our area for our second square is 625 inches squared. Our next example, we're going to be looking at 2 different rectangles. So our first rectangle has a length of 7 units and a width of 4 units. Our second rectangle has a length of 46 meters and a width of 32 meters. And like in the previous example, we're going to be filling out the chart below. But this time we have also added width because the area for a rectangle is equal to length times width. So we need both the length and the width. So now we're going to go ahead and start filling in our chart, and we're going to start with length. So box 1, 7 units. Box 2, 46 meters. Now we can move on to our next section, which is width. First box, 4 units. Second box, 32 meters. And now we're going to write it as an expression. So as an expression, we have 7 times 4 and 46 times 32. And the last thing we're going to do is we are going to solve for the area. So what is the area for both rectangles? So the area for our first rectangle is 28 units squared, and the area for our second rectangle is 1,472 meters squared. So now we have two rectangular prisms, and we're going to start by looking at the first one that just has L, W, and H. So on this picture of a rectangular prism, what does L stand for? L equals length. So what would W and H stand for? W stands for width and H stands for height. So we know the formula for volume of a rectangular prism, and that is length times width times height. So what number can we substitute for the L in the formula? And now we're looking at that second rectangular prism that actually gives us numbers. So we want to substitute for L. So we're going to take the 6 centimeters, because that is our length, and we're going to substitute it in for L. So now we have volume is equal to 6 centimeters times width times height. Can we substitute any other number for L? The answer is no, because only one number can replace a letter. So 6 is equal to L, so 6 can only be used to substitute for L. So what number can we substitute for the W in the formula? So we're going to take the 2 centimeters and we're going to substitute it in for the W. So now our equation is volume is equal to 6 centimeters times 2 centimeters times H. And lastly, what number can be substituted in for H? We're going to take our 8 centimeters and we are going to substitute that in for H. So our equation says volume is equal to 6 centimeters times 2 centimeters times 8 centimeters. So what is the volume of this rectangular prism? So the volume is equal to 96 centimeters cubed, and volume is always going to have the exponent of 3 after the unit of measure. So now we're going to be using these two rectangles to help us fill in the chart below. So what is the length of both rectangular prisms? So our lengths are 12 units and 23 centimeters. Now let's move on to do our width and our height. So our widths are 5 units and 4 centimeters, and our heights are 15 units and 7 centimeters. So next we're going to write these as expressions. So our first expression is 12 times 5 times 15, and our second expression is 23 times 4 times 7. And now our last step is to find the volume of both of these rectangular prisms. So our volume for our first rectangular prism is 900 units cubed, and our volume for our second rectangular prism is 644 centimeters cubed. Lesson summary. A variable is a symbol, such as a letter, that is a placeholder for a number. An example would be the formula for area of a rectangle, which is A equals L times W. L tells us that that's going to be our length, and W tells us that that's going to be our width. So when we have a rectangle, we can plug in the numbers for the letters. An expression is a numerical expression, or it is the result of replacing some or all of the numbers in a numerical expression with variables. So the examples would be A is equal to L times W. That is an expression. Or A is equal to 6 times 6. That is also an expression. Now go complete the problem set.